All right, in the last video, we went over crouching and crouch walking, and now we're going to make a sliding mechanic. Perfect. To start, we will need from the Adventure 1.5, we're going to need a few different sprites. We want the slide as well as the stand. There are 0, 1, and 2 for stand, as well as slide 0 and 1. The only things we need to specifically do with these sprites are on the 2 sliding sprites, set the pivot mode to custom and make them 25 by 27. We only care about it for the actual sliding because while we are sliding, similar to crouching, we will be performing the crouch function, shrinking our actual capsule size. While we're standing, it will not be crouching anymore. Perfect. All right. Now to start with our slide, we will need a few variables. Variable, as we remember, is made by just pressing plus and then setting the type here. Perfect. We need a can slide variable set to a boolean, and the default value needs to be true, as the player should be able to slide off rip. Next, we need a vector called slide velocity. This is just default 0, 0, 0. Slide cooldown as a float set to 1, and a slide boost set for now to 2000 as a vector. First thing we're going to want to do off of our enhanced input action, if you don't know what these are, I do have a previous video covering it, and I would recommend you start watching from there. Perfect. The can slide needs to be checked with a player states equal to none, as well as is moving on ground. If all of that's true, we're going to set that newly made slide velocity equal to the PaperZD characters sprites forward vector multiplied by our slide boost. Why we get the actual forward vector is to allow for directional sliding. So we're looking at the sprite itself, its direction. So right now it's facing left. Therefore, it has a negative forward vector. It would be -1. And that allows us to slide to the left. Now he's facing to the right. So that allows us to slide to the right. As -1 times whatever will make our velocity negative. Next, we want to do a jump to node called the jump name slide. Within our animation blueprint, create a jump, connect it to an animation called sliding. Within here, we just need to place slide on loop and then connect it back to our idle. Now, the transition does look different. This is for a very specific reason. We're going to use something called a transitional animation. You just need to check that here. And then open animation graph and make it the stand. You don't have an option to loop or anything because it can never be a looping animation. A transitional animation is something that is just played once on entering the transition. This could be done the same way as making another right here, calling this stand, doing the normal stand animation in there, and then connecting it. However, this adds in more logic. We would have to go to here and then check when we're done standing to go to here. Instead, we're just going to play the stand, which should play every time we're done sliding within a transitional animation. Now we need to double click here and have the rule for when we actually enter the transition. And that's just going to be whenever the player state is not sliding. Transitional animations, sorry, it's a little bit tough to say, it's a bit of a mouthful, are a incredibly useful tool. It can break down our animation graphs a bit more, and it just simplifies things. In places that we only need to play an animation once, guaranteed after another animation is where we're going to want to use this. Perfect. We're going to hop back here now. We do want to perform a crouch. And now we're going to look at something a bit interesting called a timeline. So pull up timeline, add timeline. I just named mine slide. We'll call it slide timeline. Perfect. Timeline is an incredibly powerful tool. So it allows us to do something within a set amount of time. And every tick within that time, we're going to check some type of a value. This is very useful for animations. Normally, if you want to do anything with time, you would have to work off of the event tick, pull some delta seconds, be checking it. It's something that's incredibly complicated and very messy and not optimal coding, as whenever you do anything off of event tick, even just a basic little branch, this will be checked every single tick until either the character is not called, the controller's not called, or the game is just ended, like it's just closed. So this is adding a process, while albeit very small, it's still checking every tick until the game is no longer running, and we don't want that. That's not good coding. Now, if using the event tick is all you can figure out to make something work, for now, that's perfectly fine. You have to start somewhere, and I'll show you. Here in my original character, I check on tick quite a few things. In fact, there used to be even more functions that I would check. Now, this is all I knew, and it's the only way I could get things to work. So I will show you what I have learned to make better, more powerful coding. With a timeline, this will let us create a type of deacceleration. All that needs to do is open up by double-clicking the timeline, adding a track, call it a float track. You can name it whatever. I named it slide, setting the length to 1. Now we just need to right-click here near 0, add a key to curve float 1, select it, set it to 0 and 1, times 0, value 1. Do the same thing over here, except this time it needs to be time 1, value 0. Now what this is going to do is when this timeline is started, and we want to play it from the start, we always want to start at 0 for this specific timeline. Whenever it is started, we're going to start here at 0, and every tick we're going to check this value. And what we've created is a value that starts at 1 and ends at 0. And so we see here across time it is slowly decreasing. This allows us to apply a deacceleration force to our slide. And now we need to apply this to our actual velocity. And we're going to do that by getting that slide velocity right here. In fact, now we'll just call it slide velocity. I was considering calling it initial slide velocity, but because we affect it, actually, yes, let's totally call it initial slide velocity, because we're just referencing it at the start. Yes, perfect. So this initial slide velocity, we just need to get it and break it apart, right-click it, split structure pin. All we want is the X velocity multiplied by the slide. So now we're going to have the reference to the start velocity and what it would be across a 0 to 1 second timeline from our float that is going from 1 to 0. So it will make this slide velocity decrease until it is equal to 0 from 0 seconds to 1 seconds. So at 1 second, this velocity, no matter what, will equal 0, because as we see here, the float is valued at 0 at 1 second. Sorry, I'm throwing around a lot of ones and zeros. But as we know, anything multiplied by 0 will equal 0. Perfect. Now we want to take off of the X, make a vector, pulling the character movements Y and Z velocity. If we don't keep the actual Y and Z velocity, we will then be multiplying a value that's decreasing, and if we're falling, it'll make us levitate, because falling is a negative number. Multiplying it by a fractional value will make us levitate. So we want to keep our regular velocity that is existing within the world, and not this velocity that would then start to like levitate. Or even this velocity. Yeah, no, sorry. So just make sure it's the character movements Y and Z. And now we need to set it to the actual paper character movements velocity itself. Set the player states to sliding and set can slide equal to false. Then pulling off of the finished, we can set player states to none. Remember, this is now that 1 second has passed within this timeline, we will now fire this. Player states are none. We're going to set a timer by event. I'll cover this in a second. And then we're going to uncrouch our player. The set timer by event is an incredibly useful tool. What you might think, to create a type of cooldown, you would want to delay the cooldown, be like, okay, well, we'll just set it to the cooldown we've made, and then after a second, we'll make it so you can slide again. Now, the issue with this is this delay is universal, and it's actually delaying within your CPU by a second this set of instructions, and it can start to create some overlapping issues where delays are it's hard to explain, but delays are holding back coding or overlapping with each other, and we don't want anything remotely with that. In fact, it kind of it wants to warn you about what can happen. So instead of doing that, we're going to use a set timer by event. And what this is doing is after our set amount of time, we are going to fire this event. And it's not going to slow down any other coding or cause any potential overlapping weird issues. So we're going to start here, hit this function. It's going to start a 1 second timer, as that's what we have determined will be the time amount. And then it's going to continue onward while in the back tracking this timer. So we could have more and more functions here and perform more things, and then it'll keep working through, and then boom, oh, 1 second happened. We're going to fire this event and perform whatever logic we wanted here to also happen. So things can start to happen kind of simultaneously, which can be interesting. It's not exactly multi-threading, but it's referred to as an async function. And now, after a second, we will set the can slide to be true. This allows us to have a type of cooldown, which in the future we could have it tied to a UI, tracking the amount of time that has passed on this. And just to teach, there are other things you can do with this. You can have a type of start delay. I'm not actually sure what the variance is. You can make things looping, so when this is called for the first time, it would now loop where every second it will call this again, and it'll just keep calling this perpetually until it's either stopped or the game is ended. And so we don't want that. We just want this to be called once. Perfect. And now if we play, we can see that our slide works as intended, which is great news. You can even increase things a little bit. You can increase the slide boost to something a bit more powerful. And within a second, the slide boost will come down to 0. Obviously, we're boosting further as our velocity is higher. So that can make some fun things where you could have some type of power-ups that would increase your boost or decrease it, however you would like. All right, so we went over a couple of things here. We went over a bit over vectors. Vectors are pretty powerful, very useful variables and tools. We went over timelines. Timelines are incredibly powerful. I didn't learn about them until not too long ago, and it's changed the game for me. We have talked about timer by events, and another very, very useful tool that will show up again in the future. And we have gone over transitional animations. This is, once again, another incredibly powerful tool to make things more simplified and just less bulky. I need to come through a lot of this and just clean it up using things like transitional animations. Perfect. And that should be it for this video. So if you have any questions, please feel free to ask. And as always, I would appreciate any like on the video to just get things out there more. I hope to teach as many people that are interested in this topic as possible. So hope you enjoy. Thanks for watching.